So we have three schools here, and at North Middle School we have the most students, 618, followed by Central Middle School with 378, and last South Middle School, 204. These three schools are sending their students to a conference, right? And they want delegates to represent each school. And in total, they're allowing 20 representatives or delegates to represent the schools. Altogether 20. So how many do we allow from each school? Well, of course, the largest school will have the most delegates, and then we work our way down, except it should be fair. It should be the most fair setup possible. So what we should begin to do is realize that there's definitely a relationship at work here. We have 618 at North Middle School, right, to the 378 at the Central Middle School, all the way down to the South Middle School at 204. And a nice way to deal with this one, I think, is to look at a part-to-whole ratio. So we want to add up each of the student populations to get a total population, right? To add 618, 378, and 204, so 618 plus 378 plus 204 equals 1200. So now it becomes a little bit easier to deal with because we know there are 1200 students in total. And what this means is that at North Middle, which has 618 out of 1200, we can now ask, well, what would this be equal to, x, if we allowed, right, 20 people, 20 delegates to attend. This is the population of North Middle School compared to the total population, just as this is the total number of delegates compared to the total number of delegates available. I feel like the best option is to multiply here both sides by 20. These cancel out. And over here, before I multiply 20 by 618, I'm going to divide 20 by 1,200, and that gives me 120. And then 2 by 120 gives me 60. I'm just reducing there. So now I have 60 over 618, over 60. 618 over 60. That gives me about 10.3 delegates. Okay, 10.3 delegates. And that's tough because we know we can't have 0.3. So we should keep working. Again, I'll do the next ratio here, the proportion, 378 at Central Middle School out of 1,200 students. How many would this equal out of 20? What's the fairest estimate? Again, multiply both sides by 20, right? And I'll get 20 times 378 divided by 1,200. We could simplify like before, but we have a calculator. So 20 times 378 equals, in the thousands, of course, and then divided by 1,200 is 6.3. So here, right, we have less delegates, 6.3. And then at South Middle School, what do we have? Well, we'll have 204 over 1,200. 204 over 1,200. What will that equal out of 20? Again, we multiply both sides by 20. 204 times 20, right, divided by 1,200. And that gives us 3.4. And I just did that just to make a comparison now about how we're going to round, because if I add up these delegates, I get 10 and 6, that's 16, plus 3 is 19. If I add the remaining amounts, right, what will that give me? Well, that will give me, of course, the 20 that I need. Our goal here is to make this the most fair and equitable, right, setup possible. And I think the closest or fairest way to do that is to pick D. Round down the number of delegates from the larger schools and give the smaller school one more delegate to still give them some voting power here, because and you know, there is no other choice here that really makes sense within that line of thinking, because the number of delegates at the small school should be 3.4, right? It would only be 2 delegates, which is what we have in each of these other choices, if we rounded up the other number of delegates in each school, but they're already going to dominate because they have more people. So I think it's a much more democratic process to allow the small school another candidate. But that's just my idea. But I would say D is the best answer. Thanks.